Thank you very much for the invitation. I'm delighted to be here. I remember coming to what was then Czechoslovakia a lot when I was much before I studied architecture, and always being intrigued by the buildings here, whether it was the thermal hotel in Karlovy Vary or the building, the theater just down the street where they had this Laterna Magica kind of a thing. They're very intriguing designs to me. My talk, so I'm very happy to actually be back. My talk is called Tools of Imagination. I think we've been experiencing a bit, at least at some schools, a withdrawal from the computer in these past years. Some people even speak of a death of the digital. I take the opposite view. I take the opposite position. I think we're just getting started. I think we're transitioning from using the computer as a tool of efficiency and control to one that will to a tool for exploration. I think we need we're going to start to redefine how we use the computer more as something autonomous, more as a muse, more as ultimately a design partner. But I'll get to these subjects. I'll start by asking, what can we calculate today? And I will turn to an expert to answer this question.
I don't think there's any question about it.
Will computers ever be able to work out what 9999999999999999999999999 multiplied by 9999999? Yo, I ain't finished. You don't know what I was going to say. 999999999.8899889999999999999.
The answer is yes.
The most powerful computer in the world today does 36 trillion operations a second.
So would it be able to multiply 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10? You don't know what I was going to say. Multiply, you don't even know. 10, 10, 10, 10, 10, 11, 11,
it doesn't make any difference.
13,
whatever
14,
numbers you name, the
89,
computer will be
20,
able to handle it.
100, 100, 100, 100, 100, 100, 100, 100, 100, 100,
Yes.
million.
Yes.
Thousand,
Yes.
million.
Yes. Whatever
billion.
numbers you want,
And
it will be able to multiply.
0.99998.
Yeah.
Without blowing up.
Yes.
Yeah.
Going to move it on a little bit. Where did men come from?
I don't think there's any question
Men
about
evolved out of
Will
lower
computers
species.
ever...
Okay, so I think the point is computers can calculate almost anything today. And the next question, or the related question, I think, for architects is what can we fabricate today? This is a printer in Germany. The door gives some sort of an indication of the size of it. It prints 13 metric ton heavy pieces at a resolution of 300 dpi, a layer height of 0.12 millimeters, out of sand, structural pieces. So it's a 4 by 2 by 1 meter print space. It has a tremendous resolution of 4.2 terabytes, and that, if you just think about it, it's 33 trillion different decisions about which piece of sand to glue and which one to ultimately suck out. So for the first time, there's really no cost for complexity. It doesn't matter if you print a box like the stage or the most complex form you can conceive of. There's, just like with many digital fabrication techniques, no cost for customization. It doesn't matter if you print the same form again and again and again, or a different one each time. And there are no geometric constraints. So unlike subtractive measures where you have problems of the tools getting in the way, you can deal with any kind of porosity. So I think we're at a point where there really are no constraints. Indulge me a bit. I'm oversimplifying a little bit, but I think we're certainly moving in this direction right now. And there's no constraints on neither the computational nor the fabrication side. It seems we're in a situation where we can fabricate more than we can design. And the question to me is how we can begin to think about this freedom, or how we can begin to exploit this freedom. And again, this is where my call for new design tools comes in. I don't know what they're going to look like. I suspect they're going to be related to some form of intelligence. But suffice to say, we will no longer be using the computer mouse as an extension of our pen, and we will no longer be specifying parameters by moving a slider back and forth. I think we need tools for search and exploration rather than efficiency, control, and execution. How should they be used? Towards what end? What does this imply for the architect? I don't have the answers to these questions, but what I can do, or what I will do, is I would like to show 2 or 3 projects. They're very personal interpretations of explorations in beginning to contemplate such tools. So from the beginning, I think I've been driven by this wish, however naive, to escape the references of my education. And I looked at a process which I still use today. I apologize if some of you have seen it. I'll quickly go through it. It's a division process, actually. So it starts with a very simple form, such as a square right here that gets divided and divided and divided further iteratively until very many surfaces appear. And if you just change where you place, how you divide this square, you can already begin to create, through repetition, patterns that are perhaps unexpected, or things that perhaps you weren't able to participate. The objects look like they're part of a family, but it's not evident by just looking at the output how they were created. As architects, we're interested in three-dimensional objects, so the analog of a square is the cube. And if you apply the same sort of a process, the division of the cube surfaces in 3 dimensions, you end up with a piece that looks like this, or like this, like this. So you exert control over the form by specifying, just as before, where you divide the individual surfaces. But all of these things are essentially cubes, just with the 6 surfaces have gone to 24, have gone to eventually a couple million. I'd like to emphasize, though, it's a minimal process. Even though the output is very arguably elaborate, there's a very simple input form, a cube, and a very simple operation, dividing. So that's perhaps one contradiction. The other thing is that it's a very rational process in the end that produces forms that one doesn't necessarily associate with rationality. And you can play this game by applying different factors to different parts of the form to begin to differentiate a form, to begin to sculpt it. It's free of physical constraints. So you can have impossibly small surfaces, you can have impossible angles, self-intersection, or you can begin to introduce constraints. So you could say that you can simulate a materiality to enable a tearing or a porosity, and so on. And these sorts of complications, they expand the scope of forms that can be produced. I'd like to spend just a moment on this notion of the parametric versus the procedural. There's several definitions, of course, and I think it's not a black and white distinction, but to me it does represent 2 different notions. To me, a parametric model is more about control of a form rather than an exploration. So a parametric model often works within a finite prescribed scope, rather than constructing its own solution space. So it's useful for rationalization, but it's essentially the way I see it, a constraint-based technique. Every rule must be defined explicitly. The model is established a priori, and this, I think, implies a thinking in terms of categories before you get started. But I think this digital technology, it gives us the opportunity to escape existing categories by thinking in terms of more of operations, of relations, of procedures. That's why I think I prefer to call this sort of an approach a procedural one. Knowledge and experience are acquired through search, demanding heuristics that work in absence of a categorization. So without a complex system of interrelations of the objects, in this case the faces or vertices or so on, these forms do not begin to emerge or get produced. So what does this mean for architecture? That's a question I asked myself a couple of years ago, or how could one bring this to architecture? And I, for pragmatic reasons, I looked at a column, or at a series of columns. I thought, of course, for the Greeks, columns were always an expression of technology and aesthetic sensibilities. And at least for Vitruvius, they were made according to a very prescribed script. So it wasn't a visual representation. It was more a text-based instructions of how columns should be built. Instead of a cube, I started with a cylinder, and these gradually evolved into something like this. So it's a single process that forms both the overall curvature as well as, if you just divide further and further, the surface structure. It's a process that, as you're probably aware of, you can run many times to produce permutations. And I would argue that the objects one can create are undrawable, at least with conventional means. Of course, we could draw this somehow, the plans and sections and elevations, but it would probably take a while. So we have a process, a very simple process. For instance, this division process, but it doesn't have to be that one. I think it can be any type of process you define. And as long as it's procedural, and as long as the model isn't there a priori, you have a tremendous solution space. And the question is, how does one search the space? How does one find a way to navigate all of those solutions to evaluate what the process is capable of, what is good, what is bad, what is desirable, what is not. And it's to me, it's this idea of the machine as a laboratory to try out things in, a sandbox. There's techniques we can use to help us, such as evolutionary algorithms, working with permutations, combinations. You can breed populations, crossbreed them, and so on, apply some sort of optimization, structural optimization to them, and so on. But the question that remains unanswered is really, is the one of evaluation. What do we search for? What is it that we find desirable? And I think it involves, and it's an important notion to me is that it's between control and loss of control. So I think we forfeit control, of course, over the individual vertices that are here, but we gain control perhaps over some broader attributes. We embrace the possibility of a surprise, because even though the processes are deterministic, meaning they produce the same thing every time given the same set of rules, they aren't necessarily predictable in their entity, because there's simply too many interactions that take place. How to materialize this? Back in 2010, 3D printing isn't where it is now, and the only possibility that I could think of was to produce this as a layered model stacked out of thin cardboard. Here is the column that came out. It's not a rendering, I'm happy to say. And it looked quite a bit like the one in the computer. So most of the surfaces were preserved. This is by far my favorite part. This is the inside. So it's the leftover sheets that the column was cut out of. And it's me standing in there with a very wide angle camera. And the reason I like it is because there's much more traces of the production process. So you can see the burn marks here. You can see up there a tearing of the material where the material didn't want to play along with the geometries that were imposed on it. So yes, this is one way to produce forms with limitations. It's interesting. We put up "Please do not touch" signs everywhere, but everybody ran their hands against them to try to grasp them, which ultimately I think was a compliment. And then we removed the signs because I think we aren't maybe as the history of modernity, we aren't used to so much articulated surfaces anymore, or surfaces that reveal more the closer you get. If you look at the cinema wall, I don't get new information by coming closer to it, which you would argue is the cinema might be one place where that's appropriate because the action is going on here, but there's no reason, I think, why for a facade on a building you shouldn't have something that makes you curious or reveals information. So there is a gap between the virtual. It took 35 seconds to calculate a form and 200 hours, the actual 200 hours to produce it. Of course, in terms of designing it, it took longer, but for the actual computer to calculate the production data is not even a minute. And so I swore to myself never to try this experiment again until I got a call maybe a year or so from a company that is into packaging, and they've developed a very fast laser cutter. It's slightly longer than this room, actually. And it automatically pulls paper or cardboard from a stack, runs it through the laser cutter, strips the pieces you don't like, and stacks it. And I will just show you a little bit of what's going on. So a form that took 5 minutes to cut suddenly takes 10 seconds, 7 seconds, 5 seconds. And you can, if you stand there, you will see the column actually begin to grow while you're having a coffee or a tea. This is for the expo in Astana, where I just revisited it to see how quickly they could be produced. So no longer 200 hours, more like 3 or 4 hours if the machine is running in an optimal way. And I think this opens up the possibility. I think we've all grown kind of tired of laser cutters, but it opens up the possibility of reconsidering their use as a design tool, especially when we work in not single layers but different layers stuck together. So here is a sort of a pavilion made out of laser cut sheet. Each sheet has 5 individual sheets stacked together, and the cutting time for something like this is it's not even 2 hours. Where is the context for all of this? You might ask. I got a call from Work AC, which is a design firm, architecture firm in New York. They had a building, a restoration of a house in Tribeca, which is known for its cast iron facades. And this area has become very gentrified in the past 20, 30 years. And now the very last of these, what were warehouses out of cast iron, are being restored. This is all that was left of the column capitals of this particular house. So not very much information. Everything had rusted away. And they wanted to recreate it, but they had no images of what it looked like, because while it rusted in the 30s and 40s, there was not much interest in these buildings. So we thought we found something that could be similar. There was published in 1890. There was a catalog of designs for these cast iron facades, and we took these designs, abstracted them as an input form, and ran this through a similar process to create variants of what a new column capital might look like based on what was left over. And this, through 3D printing of a mold, could then be cut in cast iron. It arguably, it looks quite similar to what was there before. And that was a necessity also, because it had to pass the Historical Landmark Commission. But what was interesting about it to me is that one could use the same process to recreate more or less faithfully something, some sort of a style, if one just figured out which rules to apply in terms of growth. These were other printing tests. Okay, that was the first project, and now I will show one more project. It is 2 grottos. These were together with a friend of mine, Benjamin Dillenberger, who's at ETH. These were also carried out at ETH largely. They started as commissions by 2 curators in France who had the hypothesis that this digital design is somewhere like grottos between the man-made and the natural. And that a building or grotto would express this dichotomy of these, or this dialectic of these 2 streams. So if you look at historical grottos, I didn't know very many, but they were either man-made artifacts that were made to look natural, or they were actual natural caves that had sort of man-made interventions of columns or so inside. It was supposed to be made procedurally, they said, fabricated digitally, and it should be at a human scale so one could walk inside it, or at the very least step inside it. So we had a context and we had an exhibition, and I'm not sure that this interplay between the foreign and the familiar, the chaotic and the orderly, is necessary. The man-made, the natural, is necessarily intrinsic to computational processes, but I think they are conducive to it. So this is one of our first proposals. The idea of a room, a space one could walk into. This is how we naively imagined the surface detail. I wanted everything in gold. So it's a reevaluation, I think, of the ornamental systems one also finds in grottos. Again, this printer that we stumbled upon then, and a first test piece right here. It's a printer that's used in die casting, mostly in the automotive and shipbuilding industries. So usually the 3D prints are destroyed after metal has been poured into them. But we thought, okay, can we perhaps treat these 3D printed molds that come out and use them as the actual construction? So we saw this printer and we became confident that we could build something. We didn't dare to build a roof over it because we didn't know how it would behave structurally. And while this printer could print 13-ton pieces at once, we had to break it down into smaller components, almost like Lego-like bricks, because transport and construction becomes an issue. There's very few museums that can have a crane that will hold a 13-ton piece, much less trucks that can wheel it around easily. And then began a very happy period of algorithmic play, of just trying out different designs in what we felt was a increasingly intuitive or speculative way. It was certainly not about efficiency and function, other than that minor structural calculations that the thing wouldn't cantilever over or flip and so on. It's a design in 3 dimensions, so not in plans and sections, of course, which was unusual for the museum, which was very traditional. They even though it was a 3-dimensional design, they demanded plans and sections of everything and elevations from all sides and cuts, just because that's how they worked. It's almost a fabrication without adaptation. The truth is it wasn't. There was a lot of adaptation to the fabrication process that went on afterwards, but we left the fabrication more or less as an afterthought. And I think back in 40 years ago, WYSIWYG, what you see is what you get, was all the rage in desktop publishing. You had the first Mac computer. It seems so trivial to us, but the idea that what you see on the screen is what you'll see on the paper when you're working in Word or so on. I think we'll get to that point in 3D printing also, where you press Control P and something very similar to what you see on the screen will come out. Hopefully also in terms of materiality. I think there's in this potentially a fusion of structure and surface. So in that sense, it's much like wood. So again, in terms of design intent between the natural and the man-made, chaos and order, the foreign and the familiar. The sections that we produced. And I wanted everything in gold, I told you. This is how I imagined details would look. And then we began gold plating everything. We started with real gold. That got expensive. We moved on to fake gold. That was still time consuming. And in the end, it was all spray painted only, unfortunately. And this is a very small detail, just slightly bigger than the hand. So once again, the idea that you can go up close to something, look into something, and hopefully discover something that you hadn't seen before. The possibility of an object or a space that makes you curious. A small size mock-up, and then we went to full scale. I can show you just very briefly how the printer prints. So it's layers and layers of sand, roughly between 0.1 and 0.3 millimeters. Sand gets glued, and then an excavation kind of starts with a big vacuum cleaner. The sand that hasn't been glued can be reused. Right now, everything is done by hand. This has been for a second grotto. It was a larger vacuum was used, so it was less labor intensive. But this is actually, after such a fabrication process, which is so high tech, begins the very, in this case, labor intensive part of cleaning the product and fortifying it. Let me jump ahead to the piece as it was assembled, the first half. So you can see quite clearly where the joints are. This was a little bit better in reality when we had a straight floor. It's so it's out of sandstone. It's 5 tons, quite heavy. And it's in terms of the basis of the form, it's exactly what I showed you in the beginning. It's in the beginning I showed you cubes from the outside, and this is simply a cube that has been cut open in the middle, and you're looking at it from the inside. So this is the pattern here that has happened, folded or developed inside of the cube. You can see the outer wall of the cube here, and this is sort of the form pressing out through the skin. So again, this virtual physical thing, it took 10 days to print, but only because they were doing a lot of car parts in between. I think otherwise it would have taken perhaps a day and a half. So it's relatively quick. The resolution is also good. The closer you get. And we keep on talking about this amazing and incredible resolution that we're able to produce, and then this happened, and this is not photoshopped, and a butterfly landed on the thing, and then it was a very humbling moment, because we speak of a high resolution here, and then this guy came along, and then okay, something new to hope for, to aspire to. Never mind the grain of sand. Can we take it bigger? We tried. I will show you. This is for MoMA PS1 in New York. which traditionally always wanted very sustainable designs. We thought, enough of this. We need giraffes, we need elephants, we need a little bit of exuberance, we need architecture for the sake of architecture and no longer an experiment in, I don't know, breeding a brick or so on. So we presented it. Klaus Biesenbach was rocking along to the beat. We thought everything was going well, and then we lost. And André Jacques won building a large water purifier, which was an interesting project, I have to say. And a second grotto came along, and we thought, and this is the last thing I'll show, and then I'll conclude. We thought, okay, maybe it's not about getting bigger. Maybe it's about really seeing, I think with this first grotto we showed, it's possible to 3D print architecture and not just a scale model of architecture. But with the second grotto we thought, what is this printer actually capable of doing? The printer in the first grotto came later. Now we knew we were going to use this printer, and we thought, how could we use it? And the main thing I think that we weren't doing yet is we weren't really working with topology. We were working only by deforming a skin rather than working with porosity, with tunnels, with branching, with, yeah, let me get to that in a second. So just to get back to this process, it always produced forms that were related to their input form, like here. So a cube could produce the top form on the right, or a sphere, but a cube couldn't produce a donut or a double donut or a teapot because they have a different genus. And then I look back at the division scheme, and this is a very big simplification, but essentially it was adapted to allow it to create complex porosity. So suddenly a cube didn't just turn into a single skin, but could turn into very many skins or into difficult systems of branching and interlocking and interweaving at multiple scales. So I think it gave us the potential for a structural ornament that's not applied or superficial, but that's what is called what we call topological. So it allowed us to move with this new process. We could move from the cube to the donut, to the double donut, and not just stay horizontally within the genus. And this was, yeah, this gives you just an idea of the different scales one can work at and the potential of this for a surface skin or the overall form. Another design. So, and once again, sorry, I forgot to say, it's the inside of the lower bottom half of a cube. That was the one thing we wanted to look at, but then we were also, I've always had this wish, and this will be my last point, I've always had this wish for a process that not only generates a shape, but also could begin to evaluate it. Because if one can close this sort of a loop between generating and evaluating, then the computer is really autonomous. I can go to sleep and wake up in the morning and there'll be something there. The question is, what does one evaluate for in the absence of functional requirements? In other words, how does one measure desirability? And how does one tie this desirability to attributes of the form? How does one measure the desirability of the form? How does one measure its attributes? And are there relations? Very briefly, measuring desirability, one simple way of doing it is just to put images on your website and seeing which ones get clicked, or measuring how long people stare at them. Put two next to each other in small, and the one that people are interested in, they will click on to make it larger. So you can get some sort of an idea. As you can see, not so many people on the website, but measuring the form is also easy. You can look at a form like this. You can begin to plot information that the human eye might not see, such as edge length or planarity, curvature, radiality, and so on. And you can look at distributions of these attributes across the form. So you could look at the form on the qualities of the face, on the relationship between faces, or even so neighborhood measures, or even on compositional measures, such as symmetry, rhythms, patterns, repetition, and so on. But I was unable to find any sort of correlation between the desirability and the output of the form, much less the input parameters for the process. Where I was finally able to find some correlation is if you bring the human perception of the form into it. So previously I was just looking at the form and left out how a person actually stands next to it. And if you measure two things, depth complexity and Erfahrbarkeit, which for lack of a better word, it generally means experienceability, then there is indeed a correlation. So by depth complexity, what is this? It comes from ray tracing, and essentially it measures how often a beam of light that emanates from a light source is refracted before or reflected before it hits your eye. So if a form is more complex, we look at it longer. And Erfahrbarkeit simply relates to how do we have to move around something in order to perceive all of it. Something that's quite easy to measure. So it turns out that shapes that are high on these two counts are at least the ones that we look at for longer, but also the ones that we're curious about and we like to enlarge or know more about. And with that, I let the computer develop forms where these two criteria would be maximized, and this is what the computer came up with. And you'll recognize this is similar to the one that I showed earlier. So there's no more input of the rules besides that. You'll also see that they're quite divergent. So it's really not thinking in terms of typologies anymore, but it's not clear what is. And I find it a bit troubling because I'm not the question of authorship, I think, is posed more strongly than in any of the other work. I'm not sure to what extent one can still claim the authorship, really. And the second grotto is simply a clustering together of these forms at different instances. So it's simply blending the output of what the computer came up with. And that's what you're looking at here. These are my final slides. Let's see, this one isn't moving yet. So the idea of a space that is erfahrbar and has this curiosity-inducing, hopefully curiosity-inducing complexity in it. These are the individual fragments. Okay, let me conclude. So I think we're at a point where we need to understand the computer, I think, as a partner in design, or perhaps as a muse, something to inspire us and to help us to be creative. To me, it's a tool. I mentioned the undrawable. To me, it's really about, or my personal interest, about making the undrawable drawable, and hopefully imagining what I wouldn't have been able to imagine. It's about celebrating, to me, the unforeseen. I'll conclude. This is my favorite quote by Louis Kahn, which he said to his class in Pennsylvania. You say to a brick, "What do you want, brick?" And the brick says to you, I like an arch. I want to be an arch. If you say to the brick, "Arches are too expensive. You can use a concrete lintel over the opening. What do you think of that, brick?" And the brick says, "I want to be an arch." So it's in the nature of the brick, I think, to form vaults or arches is how I read this. And the question for us today, I think, is what would a grain of sand like to become? Thank you.
Thank you, Michael. Some questions from the publicum?
Okay, so first, wow, really amazing. I'm curious, maybe you talk about it in the beginning, I didn't hear it, but in the process of algorithmic calculations, when exactly do you know when it is enough of iterations or subdivision levels of subdivisions? So basically, are you looking forward to in future when we have more computer power to come up to even more divisions, or as you mentioned at the end, is there also some kind of aesthetic value to know when it is enough? And then again, how that translates to the physical world.
Yeah, there's both. I mean, you reach the limits of computational power relatively quickly, especially if you work with the stuff I showed later on. But of course, the main thing is just the evaluation of the form, the difficulty of knowing, and this is something that the computer, I think, only in the last project was able to somehow begin to address, is what is desirable, what do we like, and that's something where so far the computer isn't able to replace us yet. Or for whom is the computer designing also becomes a question, because even with these tests that I showed up, that I put on the website, do people click the right or the left thing? If you break that down into regions, in terms of are people clicking from Asia or the US or something, you can actually see quite divergent results. So if you take yourself out of the process, yeah, then in that case, the question, it's a question of the audience that the computer would be working for also. Christina.
Thank you. Christina.
Thank you.
And then we have some questions from the back of the cinema.
Thank you, Michael. This was really very interesting lecture, and also such intriguing models. And a question that I found there is a quite interesting, how do you say, dialectic maybe between what you call the grain of the sand, or the scale, the one-to-one, and the scalelessness. And at some points I was looking at that and thought, wow, that would be an amazing ship in wider space, or or is that a city already? And how does the scale, what importance does scale have in your work?
It's a challenge. It's a challenge. I think in most of digital architecture, that one has the computer in front of you and you're in this scaleless world. In the software that I made to make this, I always have two buttons that I can press, and one is hand, and with the hand there's finger, and the other is person, so that you're forced to somehow think, and it's like a way of forcing myself to think in terms of a scale. For the computer, the moment the computer is evaluating it, it becomes very clear to him, because the light-based calculations require a scale. The light works with a scale, and then that's an easy way to reimpose it. But other than that, it's something where I think you very much have to force yourself. You have to do a lot of rendering. Often the OpenGL displays, I think, aren't enough. I think that's the scale on a technical level. I think the other thing for us is it's always, and it relates to the first question, it's also an exploration about how far can we go in terms of the technology. So it's really the idea of down to what kind of a scale can we get? Can we divide the surfaces more and more and more? I would love to have it at the point where we can really control, as I was saying at the beginning, which grain of sand is glued and which one is not. If we could design with that specificity, just as a technical curiosity, but we're still quite a way from that. I mean, this whole computational curve has gone up like this, and now it's, as some of you may be aware, at least on the computational side, it's been flattening out. Does that? I mean, I never have
No, I think
answer
probably
there.
other people would leave it more open also, but I think in your case it's so interesting that you seem to be very specific about scale. You really work in scale, and that's interesting that then what is the result of it actually could have many different scales, right?
That's true.
Very intriguing.
That's true. It can, and this what you see here is in the process of actually being scaled up to almost 3 times the scale. So yeah, that supports your scaleless argument anyway.
Hello.
Hello.
Actually, I wanted to thank you for the great lecture, and my question was exactly the same as Christina's. In a way, I'm really interested into, like for me, as a design tool, this fractal algorithm gives you, I guess, way more freedom in somehow finding form. So as an inspirational tool, it's really amazing in a way, I would say. So there was like, for example, if you have a plane and just if you start like altering and altering and altering, ultimately it becomes this kind of city-looking landscape that has all the towers, all the districts. You can see the arteries and so on, infrastructure. So do you have any other thoughts like in this direction somehow, like for large-scale implication as a tool for designers? Thank you.
It's an interesting question. I mean, it's in terms of using it for an urban scale. I suppose it would be possible to use a very similar logic, a successive refinement and articulation and division. I think the main difference to the work of mine is really not so much the scale even. It's the question of functionality. Of course, when you're working at an urban scale, you have all these competing functional requirements which you have to bring into some sort of a balance. And right now, the way the system is set up, the intelligence it has, it cannot address those yet. It isn't aware of those yet. Right now, every face is aware of the face next to it and maybe also of the overall form, but there are no broader functional aspects embedded into this logic. Which doesn't mean that there couldn't be. I think it should be possible with the same logic.
Thank you.
You're welcome.
Thank you.
Thank you. Thank you
Thank
very
you,
much.
Michael.
Thank you.